Quantum science is a branch of physics that studies the behavior and properties of matter and energy at the quantum level. It involves understanding the fundamental nature of particles and their interactions, which can often be strange and counterintuitive. Some potential topics for YouTube videos related to quantum science could include: Introduction to Quantum Mechanics. Quantum mechanics is a fundamental theory in physics that describes the behavior of matter and energy on very small scales. It differs from classical physics in several ways, including the idea of wave-particle duality, superposition, and quantum entanglement. An introduction to quantum mechanics could cover these concepts, as well as the history and key figures in the development of the theory. Quantum entanglement. Quantum entanglement is a phenomenon where particles become linked in such a way that the state of one particle is dependent on the state of the other, regardless of the distance between them. This phenomenon has been demonstrated experimentally and has been used in fields such as cryptography and quantum teleportation. Quantum computing. Quantum computing is a field that uses quantum mechanics to process information. Unlike classical computers, which use bits that can be either 0 or 1, quantum computers use qubits, which can be in multiple states at once due to the principles of superposition and entanglement. Quantum computers have the potential to solve certain problems much faster than classical computers, and could have applications in fields such as cryptography, drug discovery, and optimization. The double-slit experiment. The double-slit experiment is a famous experiment that demonstrates the wave-particle duality of light and other quantum particles. In the experiment, a beam of particles is directed through two slits, creating an interference pattern on a screen behind them. This pattern can only be explained by the wave-like behavior of the particles, but when the experiment is repeated with detectors at the slits to determine which path the particles take, the interference pattern disappears and the particles behave like particles rather than waves. The observer effect. The observer effect is a phenomenon where the act of observation changes the behavior of quantum particles. This is because observing a particle requires interacting with it, which can disturb its state. The observer effect is one of the reasons why quantum mechanics can be difficult to understand and apply to real-world situations. Quantum field theory. Quantum field theory is a framework for combining quantum mechanics with special relativity to describe the behavior of particles and fields. It has been used to develop theories of electromagnetism and the strong and weak nuclear forces. Quantum gravity. Quantum gravity is an area of research that seeks to unify quantum mechanics with general relativity to create a theory of quantum gravity. This is a major challenge in physics, as the two theories describe very different aspects of the universe and have been difficult to reconcile. Applications of quantum physics. Quantum physics has been used in a variety of fields, including nanotechnology, superconductivity, and medicine. For example, quantum dots, which are tiny semiconductor particles, have potential applications in solar cells, quantum cryptography, and medical imaging. The measurement problem. The measurement problem is a philosophical and theoretical issue in quantum mechanics related to the measurement of quantum states. In quantum mechanics, the act of measurement collapses the wave function of a particle, which means that the particle's state is determined with certainty. However, the act of measurement is not well understood, and some interpretations of quantum mechanics suggest that measurement is not a fundamental process but rather an emergent phenomenon. The quantum world versus the macroscopic world. One of the challenges of quantum mechanics is applying it to everyday objects and systems. While quantum mechanics describes the behavior of particles on very small scales, it is difficult to observe quantum effects in larger objects. This is because macroscopic objects are subject to environmental decoherence, which means that their quantum properties become entangled with their surroundings and are difficult to isolate. This challenge has led to the development of new areas of research such as